All right, welcome back. Today we will be going over the quiz given on February 10th. Now, the first problem, the directions were to simplify, and I want to remind you we always deal with outer exponents last. Okay? Now, for question number 1, I want you to notice there is no addition in this problem, so we are using our laws of exponents to simplify this. And I'll say this again, we deal with the outer exponent last, we take care of what's on the inside first. So you want to cancel everything inside before you deal with this outer exponent. Now, before we get started, I need you to see the difference between negative 3 quantity squared and negative 9 squared. If I write negative 3 quantity squared, we are squaring both the negative and the 3. Remember that exponents distribute over multiplication. So we are squaring the negative 1 and we're squaring the 3. Remember to see negative 3 as two separate things. You're seeing this as negative 1 multiplied by 3, two separate numbers. So since we're squaring the negative and the 3, we're going to have negative 3 multiplied by negative 3, which is the same as negative 1 times negative 1 multiplied by 3 times 3, giving positive 9. Now, if I write negative 3 squared, there's a key difference here. There's no parentheses. So in this case, the exponent is just affecting the 3, but not the negative. So here you have three things. You have a negative 1 multiplied by 3 times 3, giving negative 9. So you see up top we're squaring the negative and the 3, so we end up with two negatives and two 3's multiplying to give positive 9. On the bottom we're just squaring the 3, so we end up with a negative and two 3's. So negative 3 times 3 is negative 9. So hopefully seeing the difference. Going back to question number 1, we're going to start with what's on the inside first. So starting with negative 3 quantity squared, we're squaring both the negative and the 3. Tell students start with one thing at a time. So deal with your numbers first. Squaring the negative and the 3 gives what? Negative 3 times negative 3 is positive 9. Now on the bottom, are we squaring the negative and the 9? No, we are just squaring the 9. So we end up with negative 9 times 9, which gives negative 81. Now also, the negative is separate from the 81. So it's best to take your negative. It's just convention. Put your negative on top. So we're going to move the negative to the top. This is different from negative exponent. Just let it set on top. Now, let's look at our x's. Since we have two x's on top and four x's on the bottom, we can cancel two x's with four x's, leaving how many x's? Two x's where? On the bottom, because there were more x's on the bottom. Reminding you, x squared over x to the fourth can be thought of as x times x over x times x times x times x. And if we see two x's cancel with two x's, we're left with what? We're left with two x's on the bottom, or x squared on the bottom. Now, looking at y to the third and y to the seventh. 3 y's cancel with 7 y's, leaving how many y's? Well, hopefully you say 4 y's where? 4 y's on the top. So we have y to the fourth on the top, and we're now going to put these. So we have y to the fourth on top, and we have x to the second power on the bottom. Now, also, we still have this outer exponent. This outer exponent is positive 2. Now that we've dealt with everything on the inside, actually, I should say this, we still haven't canceled our numbers. So let's go ahead and cancel 9 with 81. Divide each of these by 9. 9 divided by 9 is 1. We don't write the 1. 81 divided by 9 is 9. Okay, so we're left with what on top? Is the negative connected to the 9? No. Okay, the negative is separate, so we divide each of these by 9, ignoring the negative. 9 divided by 9 is a 1, and 81 divided by 9 is 9. We rewrite this as what? There's a negative 1 on top. We just write negative representing the negative 1, then y to the fourth over 9x squared. And now we deal with this outer exponent. This outer exponent is a 2. Okay, I'm going to write it bigger so you can see it. And we're now going to square. Okay, do we square the negative 1? Yes. Do we square the y to the fourth? Yes. Remember that when we have parentheses, for instance, negative 3 quantity squared, do we square everything inside parentheses? Yes, we're squaring the negative and the 3. Or I should say this, you're squaring everything inside parentheses as long as there's multiplication. All right, so exponents distribute over multiplication. Squaring negative 1 is the same as negative 1 times negative 1. Negative 1 times negative 1 is positive 1. Do we have to write the positive 1? No, because we're also going to square y to the fourth. If we square y to the fourth, we multiply the exponents, we get y to the eighth. Remember, power of power, we multiply. And we don't have to write 1 y to the eighth, we just write y to the eighth. Now, we square the 9, that's 9 times 9 is what? 81. And square the x squared. Remember, when you have power of power, or taking something that already has an exponent to another power, we multiply the exponent. So we get x to the 4th power, and this is your final answer. Now, number 2, 16 plus 8 plus 4 plus 2 plus 1 plus ... We are adding forever. Remember, in order for us to figure out what this converges to, we use a formula, and that formula is a sub 1 over 1 minus r. So instead of trying to add to figure out what this thing is getting close to, use the formula. This formula works when the r value is less than 1. So, I should say the absolute value of the r value is less than 1. So how do we find r? We find r by taking the second number and dividing the first. Remember, this has to be geometric in order to add forever. So take 8, divide by 16, we get what? Reduce this, divided each by 8, we get 1/2. So our r value is 1/2. Now, r value is 1/2, and our first term, a sub 1 is 16. We go ahead and use our formula. Our formula says put the first term, which is 16, over 1 minus 1/2. Okay, 16 over 1 minus 1/2. Remember, we want 1 to be 2 over 2. Okay, what form of 1? 2 over 2. Subtract 1 over 2 gives what? 1/2. So we have 16 divided by 1/2, which is the same as 16 multiplied by the reciprocal, 16 times 2, which gives 32. If we add forever, this gets very, very, very close to 32, or we say converges to 32. If you check, look, 16 plus 8 is 24, plus 4 is 28, plus 2 is 30, plus 1 is 31, plus what's the next number? 1/2. You see that we're getting close to what? 32. Up here, again, we have what? ... So we are adding forever. Again, this has to be geometric in order for us to find this sum. And the formula for this is a sub 1 over 1 minus r. And to find the r value, we take the second number and divide the first. So we have 2 over 9 divided by negative 2/3. Now, this is not necessary. I said when there's fractions, it's very easy to find your r value. But let's go ahead and do this just to show you it does work. 2/9 divided by negative 2/3 is 2 over 9 multiplied by what? Multiplied by the reciprocal, which is flip negative 2/3, we get negative 3/2. We cancel our 2's, and when we cancel everything out, what's left? A 1 and a 1. Do we write the 1's? No. Okay, so this is what? Negative 3 over 9, and we can reduce again, divide each by 3, we get negative 1 over 3, which is negative 1/3. So our r value is negative 1/3, and our first number, a sub 1, is negative 2/3. Now, again, I said it's very easy to find your r value if you have fractions. If we look, what's being multiplied on top? To go from 2 to 2 to 2 to 2, what's being multiplied to go from 2 to 2 to 2? Well, 1 is being multiplied. 1 times 2 is 2, 2 times 2 is 2, and what's being multiplied on the bottom to go from 3 to 9 to 27? Okay, so 3 times 3, 9 times 3, we see that 3 is being multiplied on the bottom. And notice, the signs are alternating from negative to positive to negative to positive. Since the signs are alternating, we know that the r value is not positive 1/3, but rather negative 1/3. Since we have an r value of negative 1/3, and an a sub 1 value of negative 2/3, we can now use our formula, a sub 1 over 1 minus r. A sub 1 is what? Negative 2/3, so we get negative 2/3 over, let me erase, negative 2/3 over 1 subtract the r value, which is negative 1/3. Now be careful here. Subtract negative 1/3 changes to add. So we have 1 plus 1/3. And what form of 1 do we want? We want 3 over 3. So we're going to change 1 to 3 over 3. Okay, 3 over 3. And now add. Remember, what matches doesn't change. So we have negative 2/3 divided by 3/3 plus 1/3. We have what matches doesn't change. The denominator is still a 3. Add the top. 3 plus 1 is 4. We end up with negative 2/3 divided by 4/3, which is the same as negative 2/3 multiplied by what? The reciprocal, which is 3/4. And we can cancel the 3's, leaving us with negative 2/4, or reducing to negative 1/2. So our sum, if we add forever, this series gets very close to what? It gets very close to negative 1/2. Now, number 7 says sigma n equals 1 to 10 of n. What are we putting in? We're putting in 1 for n, we're putting in 2 for n, we're putting in 3 for n, 4 for n, etc. So if we put in 1 for n, we get a 1. We put in 2 for n, we get a 2. We put in 3 for n, we get a 3. And we're going to stop when we put in what? When we put in 10 for n. So this is going to go till we get to 10. Now what does sigma mean? Sigma means add, so 1 plus 2 plus 3 plus what? 4 plus 5 plus what? 6 plus 7 plus 8 plus 9 plus 10. And we want to know what this equals. Remember, there's a trick. If the values are increasing by a constant value, in this case, to go from 1 to 2, add 1. To go from 2 to 3, add 1. To go from 3 to 4, add 1. Since we're adding to get to the next value, this is arithmetic. Go ahead and write arithmetic. Okay, arithmetic. Up here, we were multiplying. Okay, multiplication was what? Multiplication is geometric, different. Okay, geometric. You have to use the formulas of 1 over 1 minus r if you're adding forever. Arithmetic says there's a trick. If it's arithmetic, we have a trick. Add the first number and the last number. 1 plus 10 is what? 1 plus 10 is 11. And multiply by half the number of numbers that you have. Since there are 10 numbers, we multiply by half of 10, which is what? 5. We get 11 times 5 is 55. If we add this up, we end up with 55. Again, just to show you, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. We can diagram. 1 plus 10 is what? 11. 2 plus 9 is 11. 3 plus 8 is 11. 4 plus 7 is 11. And 5 plus 6 is 11. We end up with how many 11s? 5 11s. So it's faster to just take the first number, add the last. 1 plus 10 is 11. And multiply by half the number of terms. Since there were 10, you multiply by half.